include the ability to play back data audibly through the speakers, convert time data between acceleration, velocity, and displacement, a batch file conversion user interface, the ability to overlay recordings, shock response spectrum or SRS plots, fatigue damage spectrum or FDS plots, tolerance lines, and the ability to automatically check for updates. So the first feature that we'll go over here is the ability to play back data audibly so you can listen to what it sounded like while you were analyzing it. So if I open up ObserVIEW here, and if I just open a simple recording here, this is it's called accelerator stomp because it is an engine revving up as somebody is stomping on the accelerator pedal. Let's put this back to acceleration. So you can see the recording there. If I reset to the beginning, on the replay tab, there is this audio channels ribbon button where I can see all of the channels in my recording, set the volume for each one, and some equalization and normalization settings here. Very fine-tuned audio experience. And if I play this recording now, you should be able to hear the engine ramping up. It looks like that audio is not coming through. Well, I apologize for that, but it sounds like an engine ramping up. I'm not sure if I can configure my remote desktop here to pump the audio through, but that's how that feature works, and that would work both in live data and post-process data. So the next feature that we'll go over is the ability to convert between acceleration, velocity, and displacement for time data. This works on both live data that is being streamed from your hardware device and on post-process data as well. So if we go back to that recording that we were on, you see this data was originally recorded as acceleration, but I can double click on the y-axis here and enable unit conversion for this axis between either velocity or displacement. And up here on the top left corner of the graph is a menu option where I can choose some of the parameters that go into these time AVD conversions. If I go to the add graph button, we have the same generic waveform graph template that we've had for a while now. But we also added an option to add a velocity waveform and a displacement waveform. These will convert all of your acceleration, velocity, or displacement channels to whichever unit you have selected here. All right, the next feature for ObserVIEW 2022.1 is a user interface for batch file conversion. ObserVIEW has a number of tools that are available to run from the command line, which are useful for writing scripts to automatically convert files without having to open and run ObserVIEW. The user interface tool makes it easier to get started with these command line tools and learn how to use the arguments that ObserVIEW supports. So if I open that user interface, you will see you have the option to add as many files as you would like to convert here. And you have the option to do some filtering, resampling, derivative and integral options to your recordings. And you can also convert those files to any file type that ObserVIEW supports. So ObserVIEW can both import and export any of these file types: VFW, MATLAB, CSV, text, UFF, WAV, or RPC. So for example, I can open the accelerator stomp recording that we've been using and say I want to resample this file to maybe just 1024 hertz, and I want to convert it to a CSV file. I need to turn off overlay here, and now Down here, this will give me the command line arguments that I would use if I were running this from a terminal. Instead of passing these into the ObserVIEW command line executable, I can just run them right here from this user interface. You see it's passing in the path to the VFW that I'm recording, the extension that I want to export it to. Sorry, we said CSV. There we go. And then -S for the sample rate that I'm going to resample to. So I can either copy this command and run it in the terminal and use that to run on other files, or I can just convert it right here from the user interface. So if I convert files, it shows the progress that it's doing. And then if I open the directory where my recording is, I can see right here, it created a CSV of accelerator stomp resampled at 1024 Hertz. Another feature available with the ObserVIEW command line is the ability to overlay multiple recordings and combine them into a single recording file, which can then be analyzed in ObserVIEW. So if I go back to the command line interface program, over here there's a tab for overlay files, and this has a couple options, either to not do overlay, or I can overlay and trim excess, or overlay files with zero padding. What those options mean is for trim excess, it will trim all of my recordings to match the length of the shortest recording that I'm overlaying. So if I have one recording that's 5 seconds long and the rest are all 10 seconds, it will trim the 10-second ones down to 5 seconds to match the shortest one. The other option is overlay files with zero padding. And what that does is it appends zeros to the recordings that are shorter than the longest one. So if my longest is 10 seconds and the rest are 5 seconds, then it will append zeros to the end of all my recordings that are only 5 seconds to match the 10-second length. So to use that, you need to have multiple files with the same sample rate. So right here, I have a couple recordings that I've resampled to 4096. That way I can see that they're the same sample rate. So if we want to overlay that one with manifold, and then say we want to overlay files and trim excess, then I can set an offset over here to align the files based on a time sample. So if I want the data starting at say 2 seconds here in American March to line up with the beginning of the data at manifold, I enter my offset there. And again, down here, you can see the command that it will run to the command line executable. It runs the overlay command, gives it the path to each of the VFWs that it's overlaying, comma separated by the offset that I will use for each file. And then again, the same extension and sample rate commands. You can run any of these filtering and resampling commands at the same time as the overlay. So this will combine the two files and then resample the output to 1024 Hertz. And if I go to my directory, you can see here it made a CSV of the American March and manifold files overlaid and resampled to 1024 Hertz. One of the new trace types getting added to ObserVIEW 2022 is the SRS, or shock response spectrum. The shock response spectrum can help quantify the potential for damage from a vibratory event by showing the peak amplitude at the analyzed frequencies. This can be compared between different events to compare potential for damage between events and environments. ObserVIEW allows you to specify both the Q and damping values and quickly see the results. The other new trace type in ObserVIEW is the FDS, or fatigue damage spectrum. The fatigue damage spectrum quantifies the potential for damage from a vibratory waveform by tracking the velocity and count of oscillation cycles by frequency. This can characterize vibrations experienced over the lifetime of the object. Even though one individual pulse by itself might not have very much damage, the overall damage from lots of little pulses can be greater. This can also be used to generate a random vibration test using the FDS test spectrum graph that can achieve the same amount of damage for a range of test durations. Together, the SRS and FDS plots make it easier to know if you are over or under testing your product. After analyzing the potential damage with FDS and getting a profile generated with the FDS test spectrum plot, you can use the SRS to determine how much you can accelerate your test while still testing your product adequately. The SRS data can be copied into the SRS test mode in VibrationView, and VibrationView will then generate a waveform to meet this SRS value. So let's see what those look like in ObserVIEW. So here I have a couple projects with two different short duration shock pulse recordings. And if I open this first one, you'll see I have the time waveform data, which is just a hammer hit and one accel response. And I have my SRS and FDS plots here. Now, normally we wouldn't be using an FDS in this situation due to the fact that it's such a short pulse duration. And you can see that the damage is very low for this one single pulse. But if we look at the SRS plot, we can find the frequencies that have the highest peak amplitudes, peak accelerations, excuse me. And those peaks on the SRS plot line up with the peaks in the FFT over here. If I open my other shock pulse project, I'll open it in a separate instance here. You can see it's the same setup here, but now I can take, for example, the trace from this SRS graph, copy it, and paste it onto the SRS plot for this project. And that way I can compare the two traces and see how the potential damage compares between those two pulses. Now, to show how the FDS accumulates with multiple pulses, I can copy this entire waveform just as a way to simulate it and explain how it works. So I copied it. Now if I put my start point here at the end, I can use Control-V to paste it in multiple times. So if we get a bunch of short pulse durations here and view the entire waveform now, you'll notice that my SRS stayed the same because that's just looking at the peak of each of these pulse durations. But my overall potential damage on the FDS plot went up significantly from when it was when I was just looking at the single pulse. I can go back and show you that again. So here my peak potential damage is extremely low, but when you apply the same pulse multiple times, now I have a higher potential damage. So with these new trace types in ObserView, we added a couple new software licenses. We have the basic license, which is free, the advanced license, the modal license, and order analysis. And now we have the new SRS and FDS license. One thing to note is that the stag feature, which we have recently introduced in ObserView for generating sign on random test profiles, requires this new FDS license as well as the order analysis license. Finally, we have the ability to automatically check for updates in ObserView 2022.1. So if I run the software and I have an internet connection, ObserView will check if there's a new version available, and it will show a notification if there is a new update available. We typically only put out a few versions per year because we like to give lots of new features in each update. So instead of releasing multiple times a year with tiny, really unimportant tweaks, we wait until we have a lot of features ready to go. So you should only see this update available notification a few times a year, but we encourage you to stay up to date on the latest features. That way you can get the most use out of them and we can get them in your hands sooner. The last new thing for ObserVIEW 2022.1 is a set of features we're calling technology previews. These features are mostly complete and working. We just haven't quite completed the rigorous amount of testing that we typically do for each feature before it gets released. This technology preview option allows you guys to get your hands on features earlier and allows us to get feedback from our customers earlier as well. These features should be complete enough to get some usability out of them, but there may be a couple edge cases where they don't function exactly as you would expect. If you see something unexpected happen while using a technology preview, please reach out and let us know your thoughts. So the current list of technology previews that we will be releasing, in ObserVIEW 2022.1 are frequency math traces, the ability to view any graph as 3D, live time filtering, and average FFTs. So we'll quick walk through each one of these and I can show you how they can be used. So if I open a project here, for frequency math traces, I can right click on any frequency graph. So for example, this FFT graph that I have up here, I can right click and say add math trace. This opens up a dialog here where I can enter my math equation for the math trace. And we also have some helpful tips over here for how to compile a math trace function. So we have the channels in our recording here, the different trace types available, math operators, and basic functions. So I can refer to channels simply by either using their name or by referring to them as V1, for example. V1, or short for variable 1, generates a variable, and I can tell ObserVIEW which of these channels I'm referring to when I say V1. So say I want V1 to mean channel 4. What this will do now is it will add an FFT trace, of channel 4 to this FFT graph. And you can see it added it to my FFT graph here, and I can right click on it and I can edit this math equation to change it to whatever I would like it to be. I can rename it to say FFT of channel 4. Or I can even change which trace type it is. So say I wanted to have the PSD of this channel on the FFT graphs so that I could compare them. If I double click PSD over there, it will add it to my equation. And then I can either do, again, V1, or I can just give it the name of the channel and say channel, let's do 3, in quotes. Remove my old V1 variable, and now this will add a PSD of channel 3 to my FFT graph. And I would probably want to rename my trace, just say PSD of channel 3. Hit OK, and now we can see we have the PSD trace added to my FFT graph. And if I add a cursor onto this graph, you can see the values of my math traces along with the FFT. So let's remove that math trace. Add another one. I can do basic math operations. So let's say I want to do V1 plus V2. and I want to sum up two channels. Again, this will do the FFT channels here because I have the FFT graph selected. If I just hit OK, now this trace here is the sum of the FFT of channel 1 and channel 2. I can also do a function over multiple variables. For example, say I want to see the max of channel 1, channel 2, and channel 3. I can call it max 1, 2, 3. And when I hit OK, it will add the max of those 3 FFT channels. So a lot of functionality that you can do and flexibility there that you can do with frequency math traces. If I go back to viewing my time and FFT graph here, the next technology preview feature is the ability to view any graph as 3D. So in previous versions, we've always had the ability to view spectrograms as 3D. You can see that here. If I check 3D view, there's your 3D spectrogram that we've had in previous versions. But now I can right click on, say, a time graph and say 3D view, or on my FFT graph. I can view this in 3D as well. If I add some more channels here to my time graph, it'll make it a little more interesting. So it gives you a unique perspective on your data that maybe you aren't always able to see in 2D. A graph that I think looks the most interesting in 3D is octave. So if I switch this to 3D, now you can see all of my octave data, and right now I have my trace bar style set to disconnected lines, but the default is auto, which is the bar trace data, and you can see all the 3D bars here for my octave data. I have the option to do bar, stair step, line, or disconnected line, which we started out on. There's also some new features to the 3D spectrogram trace types where I can specify whether I want the default surface trace, or I can change it to a waterfall, lines, wireframe, or dots. And some of these options you can change which color theme you would like it to follow. So right now I have it in light theme. The application is in light theme, which is why the fill underneath this trace is white. I can change that to palette to get this spectrum of the range of values underneath my trace color. You don't need to have a graphics card to run these 3D graphs, but of course, the more graphs you have and the more channels you have enabled, there may be some performance hits if you have a slower machine. But we do have the option here to check high performance line on trace types. Sorry, it doesn't apply to all of them, but on the FFT. So what that does is it greatly improves performance on slower machines by rendering less points on the graph. So the next technology preview feature, if I go back to just my time graph here, is the ability for live time filtering. And if I add an FFT in here again so we can see the results, when I click on my time graph, you can see down here in the traces pane, I have the ability to enable low pass filter and high pass filter. Now we've always had the ability to apply filters to data, but it was only available as an export option. And so I wouldn't be able to see the results of my filter until after exporting the recording and then opening it up in a new instance of ObserVIEW. Now I can set a high pass filter and see I want to filter out data below for demonstration purposes, we'll make this a very high frequency. And you can see the FFT updating based on the filters that I have applied to my time data. Let's say I want to have a low pass filter, and say I want to filter out data above 800 hertz. You can see some of that higher frequency data came back in when I updated that. If I put this down to an extremely low value, then we lose a lot of our frequency. Finally, the last technology preview is average FFTs. So if I go back to ObserVIEW, let's just start from scratch with a plain FFT graph here. I can check the option to view average FFTs, which is similar to the peak hold, except instead of holding the peak value for each FFT over this range of data, I can just see the average of those FFTs over that time range. I can turn on peak hold as well. So you see my peak hold is this more dashed line above, and then my average FFT is right here in the middle of those two. So yeah, that's all I have for today. Thank you for joining. We will have this new version of ObserVIEW available shortly, and we will send out this recording of this webinar to you guys so you can watch it later for reference if you would like. If you have any questions, please reach out to us and we will be happy to answer. But that's all I have. So thanks for joining and have a nice day.